Welcome, Neil. It's great to finally have this opportunity to catch up. It's been a while in the making to get to this point. So delighted to have the opportunity to speak to you today. Neil,
pleasure to be here.
And Neil is the CTO at FIDO and has an extensive background as a serial entrepreneur, as we'll dig into in just a moment. As we invite him along to have this conversation, really because valuing his views on sort of AI, getting underneath the skin of it for what it might mean in the water sector, and it's tracked closely alongside the company he is currently working for and founder of, called FIDO. So we're just going to kick off and just get Neil to give a bit of a background about himself. We've used the word there, inventor and serial entrepreneur. It'd be great to hear a bit, Neil, about what you've achieved in the past, leading up to this point.
Thank you, Ben. Hi everyone. Yeah, I think it was interesting. I was actually did a presentation to the company this week, actually, going back from the real history, and I realised, actually, having done the study, that it dates back to my dad. He was decommissioned to Germany after the war with decommissioning B-2 rockets. And he brought back little machines and gyros and this stuff, which I played with as a child. And then we really went through the whole thing of playing with Meccano, Lego. Those of you old enough to remember those. So my whole background was in that space. And then actually I went to do physics at university. Quickly realised that practical physics was far more interesting than theoretical physics. So I kind of focused more on the practical side. Went into the telecoms business, GEC originally. Wasn't for me, corporate life. Soon when I had to work for myself, that was kind of my thing. Medical didn't fit in very easily with most other people. So, and then really it went through various sort of roles, kind of trying to find my space. And really took off. I guess the first time I got exposed to the AI side and neural nets was back in the 80s and 90s when the neural nets first came to fruition. I wrote my own one on in BASIC, as it was then, on a PC to do football pools predictions. So doing time series analysis with AI was kind of where I started from. More than that then spread into doing the analytics of data. Did a lot of work for people like IBM, Virgin Media, looking for lost data circuits and lost data sets. And then really what's happened over the last few years is the explosion of the IoT, or the small sensors. And I was involved in an initial project to build a sort of a waste monitoring tool using early IoT devices. And that was a massive learning experience about how IoT, in essence, I think its phrase was the power to transform the planet, optimize the planet. And really getting into that data was the start of our journey into the water sector and FIDO. So we started building sensors to do the work, but part of that work we were looking for acoustic recognition, and that's kind of really where we built a whole system to do acoustic AI analysis in what we did. And that's kind of where we got to today. And that's really the background of what we built within FIDO.
Thanks. Yeah. So really interesting sort of background coming into this side. It always fascinates me about the skill sets which get developed, which then ultimately end up in our sector.
Yes.
What do you think it was that you learned through that, especially then thinking about for a bit further ahead about sort of AI in general, that actually made the water sector attractive in terms of coming into it as a space? What was the challenge in there which you saw?
Into water particularly, I have to say we kind of came at it from the point of view of we had an idea that we thought we could solve a problem. And it really took some of the innovation teams to kind of go, yeah, we get this. This is a good idea. We can run with this. And it really, because in a world where there tend to be quite legacy companies in the sense of their technology. They want to innovate, but actually you've got to find a hook that people want to try and use to get value from. And this is where we really think this is where the value of AI starts to become really powerful, because it just lets you simply just do stuff you couldn't do before. You have to do massive manual processes, which just takes time, resources, inefficient, requires management. And actually, by using the AI is misused to just a bit of clarity. So we talk about machine learning here predominantly. So we'll get into that a bit more perhaps, but so this is more machine learning in the typical phrase, where just taking repetitive tasks that require a really complex decision set to be made really lends itself to that whole machine learning practice. And that's really where we think we can bring massive opportunity to lots of areas. And actually, what's been interesting is how working with the companies, we spot loads more areas that can benefit from the same treatment. That's been the interesting part.
I think let's dig into that in a moment, because I think that's been one of your sort of strong points as a company and as a CTO, is you found other problems as soon as you begin to lift the lid and helping people with the data, and I think that's been fascinating. But maybe just for the help of people sort of diving into this one, that kind of differences between machine learning and AI, and are there sort of any nuances that general professionals in the sector should be aware of when thinking about those terms?
I think I think AI is the global term for all the stuff that machine learning and thinking. Machine learning is very much a subset of that, and this is really where my background was from, building these early what were neural networks or convolutional neural networks. There's lots of different types, and I won't get into all that. But these are really, I guess, in their elemental form, classification tools to say, okay, I can take a load of known data, that let me learn patterns within this data that I can then use to predict going forwards. And that's really what is, if you take machine learning, it kind of comes into two categories. You've got kind of what's called supervised learning and unsupervised learning. So the classical world of supervised learning, where you kept, in essence, massive data sets of known outcomes. So you've got, take an analogy, acoustic noise, is it a leak or not a leak? That's a very simple process. And by collecting thousands and thousands of data points that says this noise is a leak, this one isn't, this isn't, you can build a classification system quite quickly, or not that quickly, but to say, given an unknown noise, I can classify it as one of these two things. And that's really in its simplest elemental form. If you want to go the more advanced or the newer version is what's called unsupervised learning, where you in essence take massive data sets of outcomes and you're looking for patterns and clustering within those outcomes to say, can I get value from this data? So if you got, so these are typically things where you've got multi-dimensional sets of data that have got, temperature, volume, sound, weather, all sorts of sets. And can I, by plotting all this stuff on a graph, can I see a pattern that's emerging? And again, it's one of the things we learn from the, being old enough to learn from old things, is that the visualization, people are still very visual. And in fact, even going back to the really early IBM days, when they were doing these sort of, the flashing lights on these patterns, they very quickly realized that the best way for a human to see an outcome was a visual pattern being generated on the screen or a set of lights. It's far more powerful and far quicker than a printed report or something you have to read. So I don't know if that answers your question, probably not, slightly.
For me, it comes down to how, a bit of understanding on this side helps. So supervised versus unsupervised. And in terms of leakage detection, then, which is being applied? Is it a combination of both in terms of this machine learning for what you're doing?
Well, initially, you can, from the learning side, you can take, we can manually classify initially to say, okay, I've heard a noise, gone and done the investigation, is it a leak or not a leak? And you can kind of learn that process. Quite laborious, quite difficult, and expensive, but that's how we started in effect. What we then realise is you can then start to use the bigger data sets that these companies historically sit on, and actually any water company has got data dating back 50 years. And by doing some mining of that data and using the unsupervised learning models, you can start to look for data in the old data sets which you can now bring into the value chain. And the challenge with supervised learning is you have to be able to tell the system in essence, what it is you're looking for. Unsupervised learning will kind of tell you what to look for, what's maybe in there. But to do supervised learning, you've got to go, actually, I'm going to take this bit of data, I'm going to process it a bit, do some pre-processing to give it some kind of markers or viewing, and then I can teach the system what those markers are to then classify unknown things. And ultimately, it's a simple system that says, okay, I've got a known noise that sits in one or two camps, an unknown noise or an unknown file turning up. In essence, it gives you a prediction to say how close is it to one of the known cases in either of these two already. So if you get 100%, it matches really well. If you get 30%, it doesn't really match very well. So you've got to take a data view that says how good or bad that matching process is, and that's a part of the tuning you do. And part of what we also learned is you have to keep trying new methods all the time. This is one thing I learned at a conference a little while ago, and I'll attribute Hugo Fines of Electric Imp for this, is you just have to try it. There's no substitute for getting out there, getting real data and experimenting with it. The challenge, I was thinking about this morning, the challenge is that a lot of more historical companies want to do proven business cases of innovation to say, I need to know how this works, I need to know the value of it, how does it work, what's the value showing the numbers. And in a lot of cases, and one of the benefits we've had, you often just don't know the outcomes. Sometimes you get it wrong, and sometimes you just get lucky. We've actually discovered some algorithms we didn't expect to work actually gave us some great results in unexpected ways. And so in pure scientific terms, you've got, no, this doesn't work. Actually, it turns out it does.
That's really interesting. And I guess let's jump off at that point, is that as a company, and as a new entrant coming into the water side, how did you find the space to do that? Did you find, because you managed to get the investment which allowed you to develop the product as you were going, what were the kind of secrets to kind of, getting across some of that hurdle? Because it is a difficult space to enter into. Returns can be great in the longer term, but as an entrant company, scaling up, how have you found it? What were those ingredients?
I think we kind of stumbled in this. I would have liked to say it was intentional, but actually, to a degree, we stumbled into a space where we've gone into leakage. We knew it was, as an outsider, we knew it was a problem, and I think we got an answer here, guys. But we didn't really have a proof of that, and it took one or two companies that are really quite forward-thinking to say, well, actually, this is a bit of an idea. We can't prove it yet, but actually, let's try it out and see if it works. And we had a belief that we could do it, and we had an investor that believed we could do it, and we had some great pull throughs. Actually, we got a couple of companies and because in essence we solve a problem that they need, and they're being driven to solve it by the regulator. So there's a two-sided pressure here. There's actually, they have to solve it, and there's a benefit to solving it, and here's a potential solution. So we've been very fortunate that they've gone, actually, let's come and try it. Let's demonstrate we can make the process work. And it has, and what it's done, it's given them a very, very good result. So it lets us then go further to the next phase. And it's been interesting. There's been a point where we become an insider and trusted as part of what they're doing. And that's if you use the old phrase, opens the kimono a bit. You kind of then start to get exposed to other areas of business that would benefit from the treatment. And that's been an eye-opener for me, rather than saying, right, here's the solution, off we go. And again, the evolution process, we got this from the 2065 conference, was, a lot of companies will kind of do an evolution of an idea to a product phase and say, right, we've got a finished product, guys, this is what it does, let's go and sell it. And when you actually get in front of the customer, they go, well, that's not really what we wanted. It was actually, if it did this, it'd be far better. And we've learned, so we do develop with the customer. That's very much part of our ethos, to say, don't finish it before we get in front of the customer.
Wow. Okay. So that's a really interesting point, I think, is that, and also having that confidence. I mean, that must come down to something within your team and with, around you, to have that confidence to solve as you go forward, and I completely get your point around, one, there's a double driver potentially on the leakage. Everyone can sort of spot that if you look from the outside into the sector. But really, having that confidence to try and solve as you go, knowing you have, you know, particular methodologies, technologies which might fit in. How do you feel when you sort of enter into that side, or was that quite natural for you?
I think that's, to be honest, it's just that's the result of having a few grey hairs, having been around this block a few times. Actually, there's an instinct of, right, this works, this doesn't work. But what's interesting, I worked with one of the engineers we took on board, and he said it very well, was that in essence we're not afraid to throw stuff away. You know, in a classical world, you'd have built a project, you'd have invested X thousands of pounds, and you have like an invested momentum to get to that product where you continue through it, even if it doesn't work. You know, and we see several products in the market that, whilst they're finished and polished, actually don't deliver what they're supposed to deliver. But you know what happened with internally, they've gone through, we'll build this process, we've now invested this much money, we've got to make it work, we've got to finish it, we've got to do it. And we've done 2 or 3 sort of start-off bits, and we've kind of gone, this isn't going to work. And actually, we had the sort of the braveness to throw it away and say, this just isn't right. Let's go back to the drawing board, which is a kind of more inventive step, I guess. And again, just having people with experience. It's interesting. It's a combination. We've got a combination of people that are experienced, but also people that have no experience at all. So they're not limited by what they don't know. And so we've got some very young graduates that are very smart, going, yeah, we can do this. And they just go off and do it. They don't kind of think about what they can and can't do, which is brilliant.
Yeah, I think that's great. A great team dynamic in there to help it grow. I think having that culture. I mean, what screams loudly for me is that the example that you've got of developing in this space is there's certain elements for it which, you know, I think really do need to be sort of looked at in terms of how we foster innovation within the sector. There's a lot going on this next AMP period, and there's a lot of hope placed upon doing things differently. But I really like the mindset you had there about not having to finally develop product, having the structure or something, but having that open-mindedness, which is easier for certain companies, clearly, depending on where they are in their life cycle and their journey. I
think that's true, and I think, you know, the experience has been in a couple of cases. We've gone to other companies, but we've got this idea, we want to do this, and you get sent down the innovation route. And right, look at this innovation. Then, okay, right, what I need now is the 2 proven case studies to prove this all works before you get there. To me, that's not innovation. That's really just going, it's just a purchasing process. You know, you have to, if you don't, you need to engage with the concept and then evolve the idea to suit you. And again, as we talk to more companies, we realise that everyone works a different way. They all have different agendas, different needs, different requirements. So there's very few cases where the single solution is going to work anyway. We have to kind of keep evolving it and tuning it to be different cases. And you've got to have that flexibility to say we can just adapt to work in a different way. And we get, you know, we learn something new every day, to be honest. That's the short answer. It's a massive learning journey that we go through.
Yeah. There's some really good points in there. I think maybe we can come back to them as well, and sort of, yeah, fascinated by how innovation can be embedded within the sector, and I think there's some good stuff there. One question I was going to ask you, just building on this, was around skill sets within the sector. So often around when you hear AI, data scientists, and that side, how have you found that embedded knowledge across the sector? Do you think there's a sort of a skills gap there, which people talk about? Do you think it needs to be plugged either internally within water companies, or do you think it is we bring in suppliers and other technical experts as we need them?
I think it's an interesting one. I think the observationally, and I guess this is just my view, is that, and this is the old consultancy argument, that in most cases, when you actually talk to people on the ground, they actually know most of the answers themselves already. And actually, by telling you this is what we want to do, you can then formulate a solution. And often, you know, there's been people here who've been working for 20, 30 years in this sector, far longer than I'll ever do. And they have a massive amount of embedded knowledge, which you need to capture into the process. So, you know, when I was at GEC, they used to have an ideas box and stuff going through, which at the time I kind of completely ignored. But actually getting the people who understand the business to engage and go, I think I've got a solution here. And, you know, even we don't do any waste. We've had a couple of conversations with wastewater side. And again, we got a challenge, but actually you talk to the engineer again, he goes, well, actually, if we did this, we could kind of solve this, but we just haven't done it. And so I think the mechanism for getting growth, getting that innovation into the process is a difficult one for business to evolve with. The hierarchical structure doesn't really help that. So anyway, coming in as an outsider, we don't have an agenda that stops that. I think what we've seen, everyone recognises they have to do more with the data. The data, the digital twins, the data systems, and in fact, I just had a meeting this morning. You've got to have the elemental data at your fingertips to make the decisions. Most of the history systems tend to be kind of workflow based in terms of a series of events, and don't capture the elemental bits you want to know to go back and look at your history of performance. And again, because these systems existed long before electronics was around, makes it very difficult to integrate them. They are in essence analog systems that don't have digital outputs, and to make that digital transition is going to be an ongoing. The IoT world will change that over time because there will be more sensors in more places. But then, of course, you've got to then issue these massive data lakes of data that you kind of got to work out what you're going to do with, and that's a different problem. Our world is, in terms of the AI, is to push more intelligence to the edge. We have a centralized system currently because the sensors we're working with are fairly done, but actually, the vision of FIDO is to start putting that intelligence into the sensors and go, they can make their own decisions whether it's a leak or not, rather than the centralized system doing it.
So, with that in mind, what is the frontier for leakage detection? So when I look at what you've achieved and what's going on in the sector, deployment of sensors, we're having the data is being channeled back in a way and accessible in new ways and combinable with lots of other data sets, enabling us to get out there and identify things early, proactively on that side. Just really keen to see where we're pushing to on this side. What is the frontier that we're still pushing up against?
I think what it is, it's about the thinking and the way that they operate. So we can supply data and vision about what's happening in the system. Ultimately, if you take the leakage example, you've got to have a model that says, okay, I have to be, in simple terms, I need to know when a leak starts, how big it is, and how long it runs for. And the idea is obviously you're always going to. In essence, these systems are always going to leak. I was playing one the other day. In essence, you look at any typical water utility company, they've got 60-odd thousand kilometres of pipe work. So it's 5 times around the planet with a single pipe that sometimes dates back to the Victorian era. Of course, it's going to leak. It's never not going to leak. In a perfect world, if you replaced it with a complete stainless steel system, you'd improve it, but you go broke doing it, and it will never leak again. So I think you have to ultimately always accept there will be a degree of leakage. I don't think it'll ever go away, in my opinion. I know there's a zero leakage model, but I think that's optimistic, which is great. But actually, what we're realizing, you can by taking better decisions, you can improve the system. So, legacy would be that you'd send an engineer to go and investigate an area based on some outcome from an analyst. What we can do is really make a much better targeted decision to say, I can send an engineer that's better equipped to do a particular job more quickly to a known problem area to identify and fix the leak. And it's all about shortening the runtime, getting to the big leaks first, and just getting better, not better value, but better performance from the system as a whole. And again, I saw this. I saw this at GC. We had it's dated back for years, where the legacy process is hard to change, and to move from, you can train people, you can make them think differently, and it's fine with the small business, and that's one of our events we have in the small business. We can distribute knowledge. Tomorrow I can make a decision. We can change the way the business operates in 24 hours. When you've got 10,000 people, that just doesn't happen. You have to have a whole process of getting people through that workflow. So I think it's about really getting the system, make the system smarter, and getting the people to use them more smartly, I suppose would be the poor English way of saying it. And just get to, and that's what's going to drive it down, in my view.
So we're kind of building the tools. It is actually application of it, culturally, resource-wise, and understanding how to apply it across a business. Like you said, especially when you scale this up across large utilities. So, and that makes me then think, you've got non-revenue water probably is number one across water utilities globally, is the biggest challenge, or at least up there. It's always up there, top 3 or so.
Certainly one of them, yeah.
And that's even if you're lucky enough to measure it properly. The sophistication that you are building here with AI and the algorithms you've got, how then do we apply it in, let's say, more of a developing context where, is there opportunity here, against these frontiers around cost, around deployment, to help in areas, which are less sophisticated than, say, the networks we have in the UK?
I think it'll come from the, and I learned this last year. There was a thing, isn't the phone wars, where the Apple Samsung battle generated a massive amount of sensor technology for, in essence, no money. So I can now have microphones that can hear stuff that you can't hear by ear. You can have accelerometers that can detect vibration that historically would have been a sensor the size of a bean can, and it all fits in a thing the size of a thumbnail, and for a few dollars. So the reality is that we can start to build. There's new sensors and new sensing technology that will give you that listening and observational capability at far reduced cost going forward. So ultimately, I can build. I think, and ultimately, what will happen is that people like the pipe manufacturers and the valve manufacturers will make smart enabled devices out of the box. So they just need to agree a standard that works between them all, which will probably never happen. But you've got to kind of have the working solution. But it's coming. In essence, you've got self-powered devices that can communicate over sensible distances, can live in there for 10 years, 20 years, inform you of flow, temperature, pressure problems or noise problems, and again, it's like the electric car market. It's the pioneers spend the money to get it to that stage, but actually, when it becomes a volume product, acoustic loggers are now in the hundreds of pounds. They'll be in the tens of pounds very shortly, because actually, the technology becomes a lot simpler. And I think at that point where you have more cost-driven decisions to make, you can actually supply cost-effective solutions that probably link with other things. I think, for instance, a good example, people fitting acoustic sensors to meters is a good example where, so you put in a metering system, you get a free acoustic estate as part of doing that. And that will become the norm as they start to replace it. You get just more digitization in the outputs they have.
Yeah. So effectively, as we move forward through this, scale enables us to bring down the costs, so we get efficiency on that side. Do you think there's going to also be learning to share about the culture within utilities to utilize this data as well? Is that something FIDO that needs to also happen to be shared widely, or is it purely a technology side?
I think there is a will to share, and at some levels sharing takes place. I'd like to think we can enable that better, because actually we kind of have a fairly agnostic view about the technology and the processes to say, actually, we've learned this in our repository, therefore we can share this either across other companies within the country or across countries. And then we've already seen massive cultural differences between Australia, America, the UK, Belgium, Hong Kong, where and I think, as I alluded to earlier, they all have a different agenda and different needs because they've evolved in different ways, and that's always going to be true. And I think the ability to make use of the sharing, I don't think they'll share the processes, because actually they don't really. They'll all be highly localized, and that's a function of workforce costs, training, technology costs, etc., availability of technology. But I think the ability to say there's new ideas that can help you do things more easily will always be part of our ethos about what we do. And anybody who looks at the electronics market will go, there's new stuff coming out literally every 5 minutes. You can pick up the paper today, there'll be a new bit of sensor technology, a new bit of devices out there. And you've got to make the bit you've got to share is actually, how do I get value from this bit of technology?
Yeah.
And I think that's the key value we've got to kind of share within the businesses.
There's some great points in there. I think we're going to sort of rounding out from here, but my sort of final line of questions were going to be, or are around, you've got this opportunity to work with acoustic logger data. Are there any other areas of utility life, of utility challenges that you would love to get your hands on to sort of lift it and see if you could, also again, work on some of the other challenges? What else excites you about some of the things which you could work on?
I think AI will be part of it. I think we're realising there's more we can do. I mean, there's opportunity around the waste side. We know that the waste network has a much there's issues of compliance. There's also issues of safety, and also it's much older and less maintained, should we say? It's certainly in the UK, where over the last X years, the council has basically passed over the old waste systems across to the water company responsibility. So they've inherited massive challenges. And as we start to see the weather patterns change in the UK, so things like flooding events and overflow events occurring, and safety issues to go with that, we know that it's a challenge all over the place. So I think there's a lot that we can do. A lot can be done, certainly in the waste management side, in terms of sensing technology and optimization of usage, and just the mapping and tracking and performance of old assets to get them in the system. We see legacy choices. A lot of legacy systems exist. Some are updated, some are changed, but actually, again, I think your point about the coherence of what they're doing is often interesting, where there's probably bits that we think we can do, and we have to get people to kind of buy into that process. The difference with the leakage side, of course, leakage was driven by a need, whereas this is more driven by what the art of the possible, or what can be done. So I think that there's certainly if you look at the challenges, it's usage and waste. So we'd like to be able to work on the influencing part as well, in terms of customers going, how do I make better use of my water or not waste it? Because we all have a challenge where we've got to control the usage, control the losses, and get it recycled as much as better. And that kind of holistic challenge, to me, is where I think there's more that can be done.
I care a lot, so I completely agree with you around some of that challenge there. I also think that water companies do have big drivers around the environment and helping customers also save water, reduce wastage of water, and protect our waterways. What do you think around those ideas as well?
I think we have to have a more holistic approach to the way the whole thing, in terms of, and we know there's control the usage, reduce the wastage, improve the recycling, and all doing it, of course, for better cost than you did it last year, which is always a challenge of any business, I guess, particularly in the current climate. But I think, again, there's lots that can be done around the way there's behavioural changes of people to understand what they're doing with the water. There's a lot can be done in the way that it's consumed. I mean, interestingly, it's viewed as a sort of the water bill is something you have to pay. Metre in the UK is still less than 20% overall. And even when customers are given price guarantee to say, right, okay, your bill won't go up if you've got a meter in, they still kind of go, oh, I don't really want to do it. And so inertial changes in customer behaviour is always going to be a challenge. And actually being able to help with that, or be able to steer that in the way they're thinking, I think, to me, is one of the big challenges.
Yeah, I agree on that side. I didn't know the metering was down at 20%. I'm sure if people watching this will either come back and tell us if that was right or not between us.
I'm sure. Yeah, I stand to be corrected, but I mean, from my ad hoc discussions, it's around 20%.
In any case, but it is true. It's the availability of that data. What you then use it to help customers around their water efficiency and how they engage as well. So, and then also how you use that information data.
Yeah. So I think the equivalent of the smart meter, you got your smart meter for your gas, electric. You should have the same thing for the water, saying how much water I used. You know, I've lived with 4 teenage daughters, and our water electricity cost for having had X showers a day was significant, should we say?
Oh wow, yeah, I can imagine that was a pretty high bill.
Yes.
So thank you very much, Neil. We've covered a lot there, and actually I was really intrigued around some of the stuff around innovation there which has been brought out. So thanks for sharing on that level. It's been great to track FIDO's successes through the work you've done through the innovation lab, but also wider across the sector. Just like to say big thanks for joining us just for a quick discussion today, and yeah, hope to catch up with you soon when we can get out of this virtual environment.
Brilliant. Thanks, Ben. It's been a pleasure talking to you. Talk to you soon.
Cheers now.
Bye now.
Cool. So then we'll cut it from there.
Okay, brilliant. Okay, excellent. Good. Thank you for that.
Yeah, no, I really enjoyed the stuff on the innovation side. I think it's really interesting because, and I didn't want to talk about the off-what fund here because obviously we've been appointed to help run part of that off-what fund. Like we
So,
we sidelined into that. There's plenty of time to talk about that side, but I do really think I'll stop recording now so we don't have to be so long.